looking at number 30 here. Let's write our equation. All right, so first step we need to define our variables. It says Grover needed help. He wanted to purchase X number of rock concert tickets. If each ticket cost $12.50, so each ticket cost $12.50, how many tickets could he buy if he only had $75 to spend on tickets? So the total amount, okay, we know that X is going to be equal to the number of rock concert tickets, so number of tickets. And each ticket is $12.50, so $12.50 times the number of tickets that he bought. So 1250x equals 75. Now we're going to solve that. So we're going to take 75 divided by 1250. We get x equals 6. So 6 tickets. Right, he could buy 6 tickets. 31, Kevin has his car detailed. It cost him in total $474. Total, right, that would mean equals 2. The price included 100 for parts and 34 for each hour of labor. So this word tells us that's probably what we're going to have the variable with. Find the number of hours, yes. So find the number of hours performed for Kevin's car. So x is going to be equal to number of hours worked. We don't know how many hours he worked, so we're going to denote that as the variable x. Okay, we know that it cost him in total $474. 35 for each hour, so we would say 34x. The price included 100 for parts. Now we're only going to pay that one time, so that's going to be a one-time flat rate of $100, and 34 per hour is going to be equal to the total amount. So we're going to solve for x, so we need to subtract 100. We get 374, so 34x equals 374, so we're going to take 374 divided by 34, and we get x is equal to 11 hours. 11 hours. All right, looking at number 32 through 34, we're going to solve this system of equations. We know graphing, substitution, and elimination, and we can always plug it in our calculator. All right, so now this is set up to eliminate. I have the same number here, and for my y's, I need a different sign. So I'm going to take this puppy right here, I'm going to multiply it by -1. So it's going to become a -8x, a positive 3y, and a -15. Now I did that because now I can eliminate, right? The whole purpose of elimination is to eliminate a variable. If I have 3y and I subtract 3y, the y's go away. So we have 13 minus 8x is 5x is equal to 15 minus 15 is 0. We're going to divide by 5 on both sides, so we get x equals 0. Now we're not quite done because we need to find y, right? So we're going to take this x value and plug it into either one of these. So I've got 8 times 0 minus 3 times y is equal to 15. All I do is plug in the 0 for x to find y. 8 times 0 is 0, so negative 3y is equal to 15. So then we get y is equal to -5. So we know that x is 0 and y is -5. All right, same thing for number 33. Number 33 is set up to eliminate because they have the same number, different sign right here. So I'm going to take these, I'm going to add these together. I don't have to do anything because 2y minus 2y, if I add those together, those go away. The variable y is eliminated, and we get 12x is equal to 60. Right, so 7 plus 5 is 12. 39 plus 21 is 60. So now we're going to solve for x. So we're going to say divide by 12 on both sides, and we get x is equal to 5. Right now, in order to find x or y, in order to find y, we're going to take this x value and plug it in. So I've got 5x plus 2y equals 21, so 5 times 5, plug in an x, plus 2 times y is equal to 21. 5 times 5 is 25. So we're going to subtract 25 on both sides. 2y is equal to -4, -4. Alright, so then y is equal to -2. Alright, looking at number 34, that's set up to do substitution. We have x solved for. So x is equal to y plus 6. So in this equation, I see x, I could substitute in y plus 6. So I've got y plus 6 plus y is equal to 22, right? I'm going to take this value, what x is equal to, and I'm going to substitute it in or plug it in for x. So y plus 6 plus y is equal to 22. 2y plus 6 is equal to 22, so subtract 6. So we get 2y is equal to 16. So then y is equal to 8. Now once again, we know that y is equal to 8. Plug it in. So we've got x plus 8 is equal to 22. Subtract 8. We get x is equal to 14. All right, number 35, we have y equals 3x and we have y equals negative x plus 36. So both of these are in y equals form, so this is set up to solve by graphing. All right, so we're going to plug this in our calculator. Now understand, when we're looking at systems of linear equations, we're looking for the point of intersection. So right here I've got an x and a y value, I've got a point of intersection. Same thing here, I'm finding the point that the two lines intersect. So on 35 we're going to graph those and find the point where they intersect. All right, so I've graphed this is 3x. I've graphed this is negative x plus 36. We're going to find the point of intersection, so we're going to go to Menu, Analyze Graph. We're going to find the intersection. So it says lower bound, we need to be on the left side, lower left. So here's my dotted line. We need to make sure we're on the left side of that point of intersection. So once we are, we're going to press the middle of the D-pad. I'm going to scroll across to the upper bound, the right side, scroll across that point of intersection, and it tells you the point of intersection is at 927. So the x value is going to be equal to 9, and the y value is equal to 27. Now, could you have solved a different way? Absolutely, right? We could have said this is y equals, so y equals 3x, so I can substitute that in place of the 3x, right? So this y right here is going to become 3x because that's what it's equal to. So 3x equals negative x plus 36. Now I'm solving for x, right? So let's get the x's together. Let's add x here. So we get 4x equals 36. Well, then x is going to be equal to 9. Oh my goodness, same thing, right? Now to find y, we're going to plug that in. So I've got y is equal to 3 times x, 3 times 9. Well, 3 times 9 we know is 27, so y equals 27. So again, does not matter what what method you pick, you get the same answer. All right, looking at some more word problems. It says the sum of two numbers. So we're going to write our system of equations now. It says the sum of two numbers is 51, and the difference is 13. Find the two numbers. Okay, so the first thing we need to do is define our variables. So let's say we have x and let's say we have y. X is going to be the first number because the sum of two numbers. And then y is going to be the second number. So the sum means to add. The sum of two numbers, so x and y, the two numbers, if I add them together, is equal to 51. The difference, if I subtract them, difference means to subtract, x minus y is equal to 13. Now you've got a system of equations, right? So I'm going to show you how to plug that in the calculator. So let's open up a new document. Let's go to Calculate. And we're going to go to Menu, Algebra. We're going to solve systems of equations. Solve systems of equations. Two variables, x and y, fantastic. We're going to take x plus y. We're going to plug in our two equations. X plus y equals 51. The sum is equal to 51. So that's my first equation. And the difference, x minus y, is equal to 13. Oh my goodness, x is 32, y is 19. So x equals 32 and y equals 19. Now, could you have solved by elimination, substitution, graphing? Absolutely, same exact thing. 37, Sally has 21, 40, and dimes and quarters. So let's say D is equal to dimes, Q is equal to quarters. Okay, so she has 21, 40, and dimes and quarters. She has a total of 100 coins. How many of each kind of coin does she have? Okay, well, we got our variables. D is dimes, Q is quarters. We know that together she has 100 coins total. So what are the coins? The coins are the number of dimes, D, and the number of quarters, Q, is equal to 100. This is the coins. That's not money, right? So coins and coins equals coins. But now she has a total of 2140 in money value. So what we need to know is we need to know how much the money value is for each dime times the number of dimes. Well, dimes are worth 10 cents, so we would say 0.1 D. Quarters are worth 0.25 Q. So the number of quarters times 25 cents each, the number of dimes times 10 cents each is equal to the total money of 2140. So now we have our system of equations, right? We're going to do it the exact same way we just did. So let's open up our calculator. Let's go to New Document. We're going to go to Calculate, Menu, 3, and for you it's 3, 2. So solving systems of equations. We got two variables. We're going to say, okay, we have two variables, D and Q. Yes. All right, so we're going to solve the first equation. We've got D plus Q is equal to 100 coins total. And then we've got 0.1 D. So So 0.1 times the number of dimes and 0.25 times the number of quarters is equal to the total of 2140. So we know that we have 24 dimes and we have 76 quarters. 24 dimes and we have 76 quarters. Alright, number 38, we got 3 pens and 2 notebooks. $8.25 total. We've got 2 pens and 3 notebooks, $8 total. Find the cost of each. Okay, so we have 2 different things that we're buying. We're buying pens. So let's say X is pens, and Y would then be notebooks. So my first equation, I bought 3 pens, so 3 times X, because again X is pens, and means to add, 2 notebooks, so 2 times Y, because Y is notebooks, and that's equal to $8.25. Here we bought 2 pens and 3 notebooks, so we bought 2 times X, 2 times pens, and 3 times notebooks, 3Y, and that cost me a total of $8. So there's my system of equations. Again, same thing. Let's plug it into our calculator. So let's go to menu, 3, and then for you it's menu 3, 2. I'm going to plug in our 2 things, X and Y. I made them X and Y, perfect. Okay, so we've got 3X plus 2Y is equal to $8.25. Second equation, we've got 2X and 3Y, and that's going to be equal to $8. So we know that X, pens, $1.75. And we know that Y, which is notebooks, is $1.50. So X is $1.75, Y, the notebooks, is $1.50.